Thank you for watching this video. So on this video, we're doing question 11 of November 2021, question paper mathematics paper 1. And this is application of calculus, more like optimization. So let's go. Question 11, read as follows. After travel a distance of 20 kilometers from home, a person suddenly remembers that he did not close the tap in his garden. He decides to turn around immediately and return home to close the tap. The cost of the water at the rate at which the water is flowing is R1.60 per hour. The cost of petrol is this thing in rands per kilometer, where X is the average speed in kilometers per hour. Calculate the average speed at which the person must travel home to keep his cost as low as possible. So let me read this again. After traveling a distance of 20 kilometers from home, a person suddenly remembers that he did not close the tap at his garden. He decides to turn home immediately and return home. He decides to turn around immediately and return home to close the tap. The cost of water at the rate at which the water is flowing is R1 per hour, and the cost of petrol is given here in rands per kilometer, where X is the average speed in kilometers per hour. Calculate the average speed at which the person must travel home to keep his cost as low as possible. So here what we're doing, we're optimizing. So we're optimizing the cost of water and the cost of petrol while he's driving home. That's what we're doing. So I'll try to explain this. So we have let's say we have our home here. Here's our home, and we have this tap here. It's not a very nice looking tap. Here's this tap that is dripping some water. So our friend, he traveled 20 kilometers from home. Here's our friend here, driving this so nice looking, this so not nice looking car. So he traveled this distance of 20 kilometers before he remembered that he left the tap unclosed at home, right? So after traveling the 20 kilometers, that's when he remembered that he didn't close the tap. So he returned home, back home. So we are told that the cost of water is R1.60 per hour, right? So we're told that this guy is losing R1.60 per hour at the rate at which the water is flowing, which means after an hour he will have to pay this much of water, this much for water that is lost or water that is used. So now we can, so what we can say is, okay, after T hours, what will be the cost of water? What will be the cost of water after T hours? Which is after certain hours, what will be the cost of water? How can you get this? Say this times that, it's going to be R1.60 times T is equal to the cost of water. This is the cost of water. So the cost of water is a function of time. This is equal to R1.60 times time, which means to get the cost after each hour, you substitute your hour there, which is after 1 hour you put 1 hour there. After 2 hours, T is equal to 2. Put T, substitute T there. You will get double of that. So this equation here gives us the cost of water. This equation. Also, you are told something else. You are told that the cost of petrol. So you are told the cost of petrol is what? 1.2 plus X over 4,000, right? In rands per kilometer. So this part here is the cost of petrol, this one. It's the cost of petrol, this one. Here the cost of petrol is in rands per kilometer. It's in rands per kilometer. So now, after certain kilometers, right? After certain kilometers, what will be the cost of water? Which is, after a certain distance, what will be the cost of petrol, sorry. So after a certain distance, what will be the cost of what? Of petrol. So this will give us the cost of petrol. So the cost of petrol is, say this times that, we have 1.2 plus x over 4,000 times d is equal to the cost in petrol. This is the cost of petrol. This equation here gives you the cost of a petrol after a certain distance, where your x is the average speed. It's the average speed. That's what these people said. So these two things are what we're trying to optimize. We're trying to get the best possible scenario or the lowest possible cost for both your cost of water that is flowing and the cost of petrol as this person is driving back home. Okay. So now, what you want to get is the lowest cost possible, which means you want this cost and this cost to be as low as possible. Right? So you want what? The lowest cost possible. So this lowest cost constitutes two things: the cost of water that is flowing and the cost of petrol as our person drives at that average speed of x kilometers of this thing, kilometers per hour, x kilometers per hour. Right? So now, as we said, one the lowest possible cost. So one the cost of these two. So the cost of the entire thing, which is cost of water plus cost of petrol, is equal to what? It's equal to 1.6t. This one is the cost of water. This is the cost of water plus the cost of petrol is 1.2 plus x over 4,000 times d. This part here, this is the cost for your petrol. This part. So we want the lowest possible cost of everything. Right? So what do? We say, okay, we have two variables, this one and that one. This one here is a constant. This is the average speed. Right? So we have two variables, this one and that one over there. So what do we say? We say, okay, we know distance is equal to speed times time, right? Our distance here, distance traveled, is 20. Our speed is x over time. What is our time? Our time is actually, oh, okay, I see something. So, as I said, this is our distance, right? We know this is the distance traveled. So we know that our distance traveled is 20 kilometers, right? So which means we know what d is. D is 20 kilometers. Because our friend traveled what? 20 kilometers. So the cost of water plus petrol is equal to 1.6t plus 1.2 plus x over 4,000 times the distance traveled, which is what? Which is 20 kilometers. Because our friend, to return home, will be traveling 20 kilometers. Good. So, we know that distance is equal to speed times time. We have our distance. What is our distance? Our distance is 20. Our speed is x times time, which means this represents our speed, this one, because we are told that the average speed was x. X represents the average speed. I've also said here. So we know distance equals speed times time. So we have the distance, we have the speed, we have the time. So let's find what is our time is, or what the speed is. So divide by t, divide by t. Therefore, your x is equal to 20 over t. This is your average speed. So you take this average speed of yours, you substitute it there. So you have your cost of water plus petrol is equal to 1.6t, which is the cost of water plus cost of petrol, 1.2, plus speed, which is what? Which is 20 over t, right? Divided by 4,000 times 20. The 20 outside is the distance, which is that one over there. So you only substituted your x here, this x there. Then you simplify this. What do you get? You got the cost of water plus petrol is equal to 1.60 plus 20 times 1.2. Let's do that. 20 times 1.2 is 24. So it's this time that's 24. Right? Plus 20 times 20. That's 400. So we have 400 over t over 4,000. Right? This is what the situation that we have here. So let's simplify this. So the cost of water plus petrol is equal to 1.6 plus 24 plus this. What is 400 over 4,000? It's 1 over 10. So you have 1 over, the answer of this thing is 1 over 10t. So your cost of water plus petrol, which is the function of time, is called 1.6t. There should be a t here. Plus 24 plus 1 over 10t. This is the cost of water and the cost of petrol as a function of time. You can see that. So, what do you say? You say, okay, I know that the cost for my water and the cost for my petrol is given by this equation here. So I want this equation where it is at its lowest. You want this situation at its lowest point, right? So its lowest point would be a turning point of this thing here, right? And you know, at the turning point of the speed, the gradient is what? Is 0. How do you get the gradient of 0? The gradient of 0, so you know at that point the gradient will be 0, or the rate of change will be 0. So what do? You derive this and equate to 0 and solve for t. So this equation here gives you the cost of water and the cost of petrol here. So now, you want it where it is at its lowest, which is where the rate of change is 0. So if you're talking about functions, it will be the first explanation, but you want it where the rate of change is 0. So what you have to derive this, equate to 0 and solve for t. So cost of water plus cost of petrol, derivative of it is equal to 1.6. Actually, you won't be able to derive until you sort that situation out. So you have 1.6t plus 24 plus 1 over 10, t is negative 1. Take this to the top. So when you have this situation, you'll be able to derive. So now let's derive this. So the cost of water plus petrol is equal to derivative of this 1.6. Derivative of this is 0. Derivative of that is going to be negative 1 t raised negative 2 all over 10. So you equate this to 0. So this is your derivative. Right? So you equate the derivative to 0. So cost of water plus cost of petrol. This is the derivative of it, which is this thing here. Is equal to 1.6 minus 1 over 10 t squared. This is the rate of change. So you equate this to 0 and solve for t. So multiply by t throughout. What do you get? So this times t squared multiplied by t squared throughout. You're going to get 16 t squared minus 1 is equal to 0. What do you get? Then you can factorize this, or you can use the quadratic equation here. Use the quadratic equation. So what do you get? You say, okay, to factorize it, it will be something similar to this, equal to 0. So you have 4t and 4t plus 1 minus 1. Therefore, your t is equal to 1 over 4, or your t is equal to minus 1 over 4. So our time is positive, so we'll take this one here. Leave that one here. So this is the time that will give you the best possible, lowest possible cost of water and electricity, of water and petrol, right? Then now to find the average speed which they want, you said the average speed is x is equal to 20 over t, which is equal to, you know your t is 1 over 4, so your average speed is 20 over 1 over 4, which is what? 20 divided by 0.25 is 80 kilometers per hour. So this will be your best possible speed, right? So if you wanted your best possible cost, to get your best possible cost, you would have to substitute your time here on the cost of water, at the cost of water and petrol equation. So this question ends here. You got your best possible speed should be 80 kilometers per hour in order to minimize the cost of water and the cost of petrol at the same time. So we did this. Well done. I hope it is clear. But to get the best possible cost, you have to substitute your time here and there. Then you'll get the best possible cost that this guy will have to pay for both his time and petrol.